is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about definitions and terminology on system design techniques. So, define morphology. So, what is morphology? In many areas of knowledge, morphology deals with form and structure, biology and social studies, etc. These are generally morphology meaning. But what is the relation to the image processing of morphology? So it is a mathematical morphology deals with the theory, and the mathematical morphology represents the objects in image. So what are the mathematical morphologies? Used to extract image components that are useful in the representation and description of region shape, such as boundaries extraction, skeletons, convex hull, morphological filtering, thinning, and pruning. So these are the morphological mathematical models. But what is the use of morphology? So we have to reduce the image size. I have to increase in the background image. Suppose if any of the image, we have to highlight the object, or we have to highlight the background. So any of this one, we have to. It is possible with morphology. So we are using some mathematical methods, mathematical algorithms are using for morphology. So it is used to extract image components that are useful in the representation and description of region shape, such as boundaries extraction. It is first one, skeletons, convex hull, morphological filtering, thinning, and prodding. These are the mathematical morphologies. So each one we can discuss now. So what are the mathematical framework used for? So why I am using mathematical framework means it is for pre-processing. Pre-processing nothing but a noise filtering, shape simplification, and etc. So pre-processing means before what we are going for the processing, that is called pre-processing. But what are the pre-processing techniques are there means noise filtering and shape simplification. Noise filtering means reduce the noise with suitable filter. With suitable filter. So enhancing object structure. How we are enhancing the object? If I am taking any of the object from the image, so how we are enhancing means I am highlighting the object from input to output. So what are the techniques I am applying for the object enhancing? So that is one. So what are the techniques I am using for enhancement of object means skeletonization and convex hull are the algorithms or methods for enhancing the object structure. Another one is a segmentation. So we know that how many segments are there. Suppose here in this image one photo frame is there. Some objects are there. So how many segments are there means it is one segment, it is another segment, it is another segment, like this. So we are showing as a different items, different objects in the frame, in the image. That is a segmentation. So what is the technique I'm using means watershed technique. So quantitative description means area or perimeters. These are the methods for quantitative description. These are the mathematical framework used for morphological algorithms, that is pre-processing, enhancing object structure, segmentation, quantitative description. These are the mathematical frameworks. And set in mathematical morphology represents objects in an image. Binary image, that is 0 is equal to white, 1 equal to black. Here we are taking the element of the set is the coordinates of x comma y of pixel belonging to the object as minus z2, and the grayscaled image, the element of the set is the coordinates of x comma y of pixel belonging to the object and the gray levels as z3. So here I am taking one a and b. X and y are the coordinates here. It is a 2D. X, y, z means it is nothing but a 3D. So if I am taking the 2D, how many coordinates means x comma y? So I am taking as a 0 white and 1 is a black. So the element of set is a coordinate of x comma y of pixel belonging to the object of z2, and it is a binary image. If we need in place of binary, we have to take the grayscale. Grayscale means white and black, in the form of white and black. The element of the set is the coordinates of x comma y in the pixel belonging to the object, and the gray levels are z3. So these are the objects of the coordinators. Okay, so here it is between x and y, it is in between y and z, it is between x and z. So these are the three coordinates are formed here. Here only x and y with the positive coordinators, but here the different coordinators are there with the different elements in the xyz coordinators in 3D. It is a 2D, and there are 5 binary morphological operations. The question is that what are the 5 binary morphological operations? So there are morphological operations are in the form of binary. Those are erosion, dilation, opening, closing, hit or mistransform. These are the 5 binary morphological operations. So erosion and dilation are related to 1, and opening and closing are related to 1. Hit or mistransform is another method. So this is using for one method. It is exactly opposite to each other. It is exactly opposite to each other. It is another form of hit or mistransform. It is equal to erosion and dilation. So what is erosion? See here, we are increasing to decreasing order, we are decreasing to increasing order. So erosion means how many objects are there. We have to highlight the object. Everything we have to about the object with foreground or background. We have to highlight foreground or background. That is the important thing. So combining of opening and closing. Opening is nothing but if I am taking the opening is an object, that is closing is a background. So if I am taking, if object is opening, then background is nothing but a closing. So it is a combined to opening and closing, but it is keep general shape but smooth with respect to object. So these are inversely proportional. These are exactly opposite to each other. Here, what is erosion? Erosion is nothing but it is the structure element which is fit in the set of structuring element of the original image. So here structure element is B, image erosion is A, and the output is A, erosion B. The symbol is called erosion symbol. So A eroded B. That is the B of A. Okay, what is the process we will discuss? It is only formula. Here I am taking one example. It is A eroded B. Here are we removed the items are there. It is a SE means structure element. Here structure element is SE, and we are decreased number of pixels. Here increasing the increased the black cells, but here decreasing the black means here black are increased, white is decreased. Here white is increased, black is decreased. How means we will discuss now. So here figure A, it is a set A. Here it is a square structure. So it is set A and B is a square structure element. So that is what are the border values are there means D by 8, middle one is a 3D by 4, D by 8 to D by 8, and it is a 3D by 4. It is a eroded B. A erosion B is going on. So here figure C is the erosion of A, erosion of A by B. D1 is a elongated structure element SE, and output is a erosion of A using the element. So here after the erosion, what is that means? It is one line, proper line is there. So remaining all we are decreased. So here only I am taking D is the height, D by 4 is the width. But here D by 8 is the width here it only D by 4. But 3D by 4 is the center point of this one. So D by 8 to D by 8, so middle point is a 3D by 4. But here total width is a D by 4. So we are we are decreasing from input to output. So if I am taking the 3 by 3 square of structure element, it is a structure element, that is a 3 by 3. So what are the coordinates means? -1, -1, 0, -1. Middle one I am taking as a 0, 0. So leftmost is called 1, 0. It is called -1, 0, and it is a -1, 1. It is 0, 1, and it is 1, 1. Here -1, -1, 0, -1, 1, -1, like this. So how many are there means? 2 cube equal to 8 coordinates are there. So total 3 by 3 means 9 pixels with 9 coordinates are there. So 8 possibilities are there, 0 to 8, total 9 coordinates. Next one is a dilation. What is dilation? Dilation is an operation used to grow or thicken objects in binary images. The dilation of a binary image A by a structure element B is defined as A dilated B. It is the equation. This equation is based on obtaining the reflection of B about its region of origin and translating, that means shifting this reflection by Z. So already we discussed erosion. Now what is dilation? Dilation is an operation used to grow or thicken objects in binary images. The dilation of a binary image A by a structuring element B is defined as A dilated B. This equation is based on obtaining the reflection of B about its origin and shifting this reflection by Z. Here the dilation of A by B is the set of all structuring element origin locations where the reflected and translated overlaps with A by B at least one element. Here I am taking input image, I am taking as A, structure element I am taking as equal to B. So the dilation of A by B is a set of all structuring element, that is B, the location where the reflected and translated of A, B by A. What are the structuring element of this one? Is a dilation. Okay, so these are the structuring element, cross verifying this one. So A dilation with B. So B is the structure element, A is the input image. And what are the inputs and outputs, opening and closing? So input image has two types: opening process, closing process. In the opening process, first erosion process, after the dilation process. In the closing process, first dilation process, after the erosion. So first input eroding, after then dilating this one. Here first dilating, after then eroding this one. So images are dividing as input images of opening and closing. Opening means erosion after dilation. Here first dilation, after then erosion. So it is taking one example of morphological operations of 4 basic morphological operations are used in the processing of binary image. First one is a original image, that is the input image. So here eroded means number of black cells, number of are reduced. So here somewhat we are reduced the black, so increasing the white color. Here dilation means we are increasing the black, so black is increased. Here black is decreased. So black is increased means background, what about background? Background of white is decreased. So here black is decreased, means white of background is increased. White is nothing but a background, black is nothing but a foreground. Here also black is a foreground, white is a background. So here inversely proportional. Erosion means background is increasing and object is highlighting, not highlighting, object background is highlighting. In the dilation, we are highlighting the object and we are not highlighting the background. Opening is nothing but here number of, it is related to erosion, it is related to dilation. So here also same looking like this one. There is not much change of this one. Opening means what are the small changes are there, that only I was changed. Here dilation means it is related to some dilation. Only small modifications are done. Here major modifications are done here. So erosion, dilation, and the applying of these operations to the image, that is erosion, dilation, opening and closing is on. So what is opening and closing? There are two important operators from mathematical morphology. They are both derived from the fundamental operations of erosion and dilation. Like those operators, they are normally applied to binary images, although these are all also gray level versions. The basic effect of an opening is somewhat like erosion, in that it tends to remove some of the foreground or bright air pixels from the edges of regions of foreground pixels. So what is opening and closing means? There are two important operations from mathematical morphology. So what is opening and what is closing? So they are both derived from fundamental operations of erosion and dilation. So it is from erosion and dilation. These operators, they are normally applied to binary images, although they are also gray level versions. The effect of opening is somewhat like erosion, in that trends remove somewhat foreground pixels from the edges of regions, but is a foreground. Opening is somewhat a remove of foreground. Remove foreground pixels from edges of the regions. So it is exactly opposite. Remove foreground means here what is happening means remove object. Object means remove foreground means object. Here remove background. So opening is nothing but a remove the foreground, closing is nothing but a remove the background. So these are about the opening and closing. However, it is less destructive than erosion in general, but morphological operators exact operation is determined by a structuring element. The effect of the operator is to preserve foreground regions that have a similar shape to the structure element, or that can be completely contain the structure element while eliminating all other regions of foreground pixels. So when I'm going for the discussing about opening and closing, it is not about the image, it is also about the segmentation, SE. Okay, it is a destructive erosion of general, but morphological operation, that is the exact operation determined by the structuring element. It is about the structuring element also. Okay, so the effect of operator is to preserve foreground regions that have similar shape to the structuring element, or that can completely contain the structure element while eliminating all other regions of foreground pixels. So it is the original image. It is the original image. When I'm going for the opening, what is happening is it was removed. Some unnecessary white are removed here. Here only black is there. Okay, what is happening means opening, removed objects. Okay, in the what is closing means we are increasing. We are increasing. Okay, remove the objects. Objects is removing means for background is improving. background is improved. Here foreground is improved. Here foreground is improved. So opening followed by closing. Here means opening followed by closing means opening and closing techniques are applied here. So here there is it is some shapes are there like this, but here there is no shape. Only the rectangular diagrams are showing here. Okay, it is a combination of opening and closing. So original image, opening and closing, and opening and closing. So image segmentation techniques are majorly three types: edge-based technique, region-based technique, threshold technique. So edge-based technique means what are the advantages means works well when the edge is prominent. Region-based technique means advantages is better for noise image where edges are harder to identify. And advantages is that one of the best and easiest technique is that. And what are the disadvantages of edge-based technique is could not be applied on images having many edges, not suitable for images having smooth edges. Region-based techniques are the disadvantages, but is that seed point must be specified. Different seed points may give different outputs. And the threshold technique is nothing but a could not applied on image having complex intensity distribution like medical images and cannot process the images whose histograms are nearly unimodal. Okay, so image segmentations are three types: edge-based technique, region-based technique, threshold technique. So segmentation technique majorly based on discontinuity and similarity. Image segmentations are majorly two types. It depends based on discontinuity, based on similarity. So based on discontinuity, edge-based technique. Based on similarity, threshold-based, region-based, spatial theory. So three types are there. So in the spatial theory, neural network-based, cluster-based, wavelet-based. So these are the. But majorly we are discussing about edge-based, threshold-based, region-based, spatial theory. So segmentations are based on discontinuity and based on similarity, edge-based, threshold-based, region-based, and spatial theory. So what is line detection? Detecting a line in a certain direction requires detecting adjacent points in the image in the given direction. This can be done using filters that yields significant response at point aligned in the given direction. For example, the following filters are like this. If I am taking this one, so here already minus 1, minus 1, minus 1, 2, 2. It is a middle one is there. Here like this. Here like this. It is the line edging technique. Okay, highlighting the line in the vertical, horizontal, plus 45 and minus 45 direction respectively. This can call line direction, and this can be done against two steps. Filter the image using the appropriate filter. Apply an appropriate threshold. So, what is line detection means? Detecting a line in a certain direction require detecting adjacent points in the image in the given direction. This can be done using filters that yields significant response at points aligned in the given direction. Okay, so these are the highlighting lines of vertical, horizontal, plus 45 and minus 45 respectively, and it can be done of two steps: filtering the image using an appropriate filter and apply an appropriate threshold, that is a maximum value. These are the line detections are there. It is the example of line detection, detecting using the filters. Here example of line detection. First one is a original image. And figure B, C, D and E. So B to E. B to E nothing but a detected lines in the vertical, horizontal, plus 45 degrees and minus 45 degrees. Okay, we can observe here middle one is a some white color is there. Here white colors are there, but here in the middle what are the white colors are? It is filled with black. Here white, but here filled with black. Here also black. That means from original figure to A to B, the majority of white cells are filled with black. From B to C, it is somewhat reduced. It is some identifying image segmentations are there, but it is unidentified segmentation. Here, not good segmented, because black cells are increased. So majority of black cells are increasing here from BC to DE. So that is the reason white is converting to the black. Here background is completely black. Background almost black. Here somewhat white is there, but here white is reducing completely. Almost 90% is converted to the black. That is the line detection process. In this line detection, vertical, horizontal, plus 45 degrees, 45 degrees are respectively changing the values. Okay. Define region-based segmentation. This approach consists of partitioning an image into regions that are similar according to a certain set of criteria. The region-based segmentation technique involves an algorithm making segments by dividing an image into various components that have similar pixel characteristics. This technique searches for small or big chunks in an input image for segmentation purposes. It will either add more pixels to the selected chunks or further diminishing chunk points into smaller segments and merge them with other smaller chunk points. Okay, so region based segmentation, it is completely regions of the cells or images into smaller according to a certain criteria. So the region based technique involves an algorithm making segments by dividing an image into various components. So I'm taking as an image, various segments are there. So how many? It is one segment, two, like this. So making segments into dividing of an image of various components that have similar pixel characteristics, and this technique searches for small or big chunks of input image for segmentation purposes, and it will either add or more pixels of selected chunks, further diminishing that small segments, merge them with other small chunk points. Okay, it is a region based technique. It is one example of region test, means gray level converted to the color. There are two more basic techniques based on this method: region growing and region merging and splitting. Region growing and region merging and splitting. Region growing means regions are improving. Region merging means we are adding multiple regions and splitting of those stuff to reducing the image size. So here, what is the input is that it is a gray levels are there. Here color levels are there. In the color levels, we are easily finding out what is the segmentations are there. Suppose you have one cap is there. So what is the size is there? Suppose background one item is there. So what is the segmentation? What is the face? Or how much? What is the eyes? So we are divided as segments. Segments are identifying easily. Here segments are identifying easily. So that is a technique based on method for region growing and region merging of filters. So these are the references of image segmentation. So the overallly we discussed morphology. Morphology is nothing but we are changing the object to background or background to object improvement. So it is a mathematical morphology is used. Here mathematical morphology represents objects in image. So what are the mathematical morphology techniques? Means boundary extraction, skeleton, convex hull, morphological filtering, thinning and pruning. These are the morphology techniques are there, and these are the mathematical frameworks: pre-processing, In the pre-processing, noise filtering, shape simplification is using, and enhancing object structure means skeletonization, convex hull, and segmentation, watershed, quantitative description, area, and preliminaries. In the mathematical morphology, we are dividing as a two, that is a binary image and a grayscale image. Binary image is nothing but only binary values, that is 0 and 1. 0 means white, 1 is black, that is a binary. Grayscale means the element of the x and y pixels are changing the object of the gray levels. So we are changing the gray levels. Suppose gray level is, suppose 128 is there, we have to change to 256. Here 56 is there, change to 0. So we are changing the pixels of the object in the cells. That is the xy of the pixel belonging to the objects and the gray levels. And there are 5 morphological operations are there: erosion, dilation, opening, closing, hit or miss transform. So erosion is nothing but the element of set with the combination of structure element. It is one example. It is coordinates. What is dilation is? It is nothing but a dilation is an operation used for grow or thicken objects of binary. The dilation of binary image A by the structuring element B is defined as A to P. This equation is based on obtaining the reflection of B about the origin. Okay. Origin means I'm taking the image A and the structure element is equal to B. Okay. Structure element is mapping with image A to finding out the dilation process. And the dilation of A by B is the set of all structuring element origins locations where the reflected and the translated overlaps with A by B. Here, opening and closing processor inputs are there. First input is if opening, first erosion process, after that closing process. In the closing process, first dilation, after that erosion. It is an example of erosion, dilation, opening and closing from the original image. Here, what is opening and closing? There are 2 important operations are there in the morphological, in the mathematical morphology. Those are derivative from fundamental operations of erosion and dilation, and normally applied to the binary images. Although there are gray level versions are there. Already we discussed the binary image is one type, gray level versions are second type. But the basic effect of opening is somewhat like erosion in that tends remove some of the foreground pixels from edges of regions or foreground pixels. However, it is less destructive than erosion in general. Other morphological operations are exact operations of determined by a structuring element. But the effect of the operator is to preserve foreground regions that have a similar shape to the structuring element or that can be completely contain the structure element while eliminating all other regions of foreground pixels. Okay, it is the original input image. It is converting to the opening, means some what are the white color are there, we are reduced here, converting to the black. Here somewhat we are improving this one. Here opening and closing means a combination of opening and closing. Here we are finding out as it is looking like a segments. Image segmentations are majorly 2 types: based on discontinuity, edge based, based on similarity, threshold based, region based, and spatial theory. It is a line detection. Line detection means we are finding out the vertical, horizontal, plus 45 degrees, minus 45 degrees of the matrix horizontally. There are two steps are there. Filter the image using appropriate filter. Apply an appropriate threshold. That is a maximum value. If I am taking the threshold value means maximum value. So if it is a threshold value, means value, maximum value. Suppose 0 to 2. Here 0 to 2. So this is the maximum value. That is a threshold value. Apply the maximum value. Okay. It is an example of line detection. And it is a region-based segmentation. We are converting to the regions. Here gray level to color image with the segmentations. That is the regions. There are 2 basic technologies are there. That is a region growing and a region merging. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.